What's BeamX? Well, in one sentence, BeamX is Beam Confidential DeFi Experimental Network that's going to be launched in November. Sounds cool, but what's in it for you? Let's find out. Hi everyone, I'm Alex and you're watching Beam Pulse, episode 9. So let's start with a little bit of ancient history. Back in June, Beam has activated its second hard fork, which included several important features, such as Lilantos Mimblewimble, which allowed us to build max privacy transactions and offline transactions, Beam Hash 3, which was a new consensus protocol, and also confidential assets. Confidential assets allowed you to create new types of assets, new types of tokens on top of Beam network. And unlike Ethereum ERC20, it did not require any contracts. It was implemented in layer 1, and the new tokens inherited all the same properties as Beam itself: confidentiality, scalability, and everything else. Even the asset type was hidden so that when you create a transaction, it does not show neither the amounts, of course, not the identities, and not even the type of the asset that was traded. A month later, Beam has announced its plans to build a confidential DeFi platform and published a few articles on this subject in which we explained how this is going to work and provided several examples of such DeFi applications. Now, for most people, DeFi is closely associated with smart contracts. And according to the Wikipedia definition, smart contract is a computer program or a transaction protocol which is intended to automatically execute, control, or document legally relevant events and actions according to the terms of a contract or an agreement. I liked another definition more, the one provided by Nick Szabo in 1990, which says that smart contracts are actually a set of promises specified in digital form, including protocols within which the parties perform on these promises. So at that time, Beam did not have smart contracts, which is why we intended to use Scriptless Scripts in order to implement these applications. The idea of Scriptless Scripts is that all the calculations are actually done off-chain, and only their validation is performed on-chain by each node in the network. In our case, examples of such applications include Beam Atomic Swaps, which is already running on Beam today, and also we had provided some additional examples like, for example, perpetual swaps, which is variation of futures contracts, and several others. DeFi applications that could be implemented using the Scriptless Script idea. These applications could only be limited to peer-to-peer style applications. And even though we have an SBBS system that allows easy communication between wallets using encrypted messages, we wanted to do more. We wanted to implement such applications like confidential stablecoins, lending platforms, and also automated market making based decentralized exchanges. So it seemed like we needed smart contracts after all. And even though initially it was kind of difficult to imagine how we could build this on Beam, and obviously more difficult to imagine how we could do this quickly, an old friend came to help us with this. Yes, I'm talking about Mimblewimble. How? Well, this is actually an interesting story. A standard Mimblewimble transaction includes inputs, outputs, and kernels. And while inputs and outputs are removed from the blockchain using the cut-through feature, the kernels remain forever stored in the blockchain and hence are best suited to carry additional information. And we use them, for example, for relative hash logs that are used in Laserbeam and several other applications. While developing the Lilantos Mimblewimble implementation, Vladi Gelfer, the Beam core developer who was working on this, noticed that actually it's very useful to add to these kernels an ability to provide additional information to the node, and in the case of Lilantos Mimblewimble, for example, to take some inputs and convert them into the shielded outputs that are stored in the Lilantos shielded pool. And then he thought maybe it could be possible to generalize that idea and basically allow kernels to implement various different side effects. What's a side effect? It's basically a modification of the node state. For example, we can define variables and store some values in them. Or we can add and call methods that will perform various operations on these variables. You see where I'm going with that. So then we have taken all of these variables and methods and we have wrapped them together in a program that we call Beam Shader. And this Beam Shader encapsulates all the data and all the methods, and it can be accessed by sending various types of transactions with different types of kernels to the node. And of course, in order to run this program, we need some kind of virtual machine. So we have added one. Beam Virtual Machine is based on a WebAssembly, which means that you can use several different programming languages to implement our version of smart contracts. And it could include C++, Go, Rust, or any other language which can be compiled into WebAssembly code using LLVM. So what does it allow us to do? Basically, it allowed us to create a hybrid between UTXO-based cryptocurrency like Bitcoin or Beam and account-based cryptocurrency like Ethereum within one unified model. So what are Beam shaders? Beam shaders are programs that are implemented in any of the programming language I mentioned that could be compiled to WebAssembly and that are running in Beam node using Beam Virtual Machine. Some of the key properties of Beam shaders include the ability to ensure bounded execution time. Shaders can only be invoked by transactions, which means they're completely reactive. The shader cannot act on its own. Shaders can collect fees, and they can also call other shaders, basically generating this flexible structure like you have in any smart contract platform today. In addition, shaders can control assets, which means that a shader can both emit and burn the asset it controls, and nobody else can manipulate this asset manually. Shaders can lock and unlock funds, acting as vaults or pools of liquidity or anything we need them to be. And of course, shaders implement overdraft protection on the virtual machine level, so we can make sure that only the amount of coins that was locked will be unlocked and no more. Which brings us to the question, how do we interact with these shaders? Since Beam is a confidential cryptocurrency, you obviously need your wallet to be able to sign these transactions and kernels using your secret keys. The wallet should be able to select UTXOs, which is something the wallet does today, but also to create different types of kernels with all the required information and signatures to be able to perform various types of operations that are required by Beam shaders. This sounds quite complicated. So in order to simplify this process, we have created this architecture in which the wallet can also run another type of shaders called wallet-side shaders, as opposed to chain-side shaders that I have previously described. The idea is that the creator of the chain-side shader can also create a wallet-side shader which will wrap all the functionality required to create transactions that will access methods and variables of the shader running on the node and present a clear and simple API to the wallet or any applications that will require this functionality. Not only the creator of the original shader can provide this, but also third parties. And this means that we can actually create various complicated applications that combine the functionalities of several different shaders on Beam and provide a unified UI for all of them to create different types of applications. Beam shaders in the wallet have access to the wallet native APIs, the UI of course, and also to the web application platform that will be released in 5.3. The web application platform allows us to have a built-in app store within our Beam UI wallets and have various applications, like for example, in this case, Red Envelope, which does not require contracts, but is still very cool. Of course, these applications can either be centralized, means served from some centralized servers, or decentralized and distributed using our built-in decentralized SBBS system. Each application is basically a combination of HTML and JavaScript, and the JavaScript can access both the native wallet APIs and the wallet-side shaders to invoke any functionality that we need to work with either the wallet or the smart contracts, the Beam shaders that run on the Beam network. This is very flexible architecture, and it allows you to basically do almost anything. You can take existing shaders and build new UI above them very simply by just writing HTML and JavaScript, or if you want to perform certain operations, more complex ones, you can create new shaders of your own. Obviously, the wallet side shaders are less limited in their resource consumption than the node side shaders, the chain side shaders, because you wouldn't want to consume too many resources on the node running in the network and processing a lot of transactions, but you can afford to do so in the wallet. Which brings us to this overview of the Beam ecosystem. In the middle, you can see the node architecture, which starts with BeamHash3, our consensus algorithm at the bottom, followed by Dandelion, Mimblewimble, Lilantos Mimblewimble, Scriptless Scripts, and Confidential Assets. All of those are already active on Beam network today. On top of that, we're adding the Beam VM, and then we can create various types of applications running inside our wallets, backed by both wallet and node functionality on layer 1 and also our Beam shaders running as kind of smart contracts on layer 2. And these applications will include Beam DEX, which is decentralized exchange, atomic swaps that are already working today, and we're adding more functionality, like, for example, atomic swaps with Ethereum, and also in the future with ERC20 tokens such as DAI and Uni and others. And of course, App Store and different web apps that will be developed both by Beam and also third-party developers. And this will allow us to create and build decentralized bridges, algorithmic confidential stablecoin, Beam Swap, which is automated market maker exchange, and Beam Lend, which is the lending platform. All of those will be implemented during 2021. And so, as I said, BeamX Confidential DeFi Experimental Network will be launched in November, and we will invite everyone, both users and developers, to participate in the launch. It's definitely going to be exciting and something to wait for. In the meantime, have a great day.